Hi all, welcome to BRR Knowledge Center. In this session, we'll talk about API gateway. We'll see the introduction part of API gateway and also we'll discuss the cool features of API gateway with respect to microservices. So as we discussed in the earlier session, so the current trend was uh, microservices architecture. And to manage these different kind of microservices, so we must require an API gateway. So API gateway is nothing but a single entry point for microservices, which will sit between client and backend services. So this simply it is a gateway tool which will sits between a client and a collection of backend services, nothing but microservices. In this session, I'm going to give you an overview about the API gateway. So we will see what is an API gateway, how can we use it into the context of microservices, and what are the benefits such as security and latency of our applications to application scaling. Let's get started with the definition. So coming to the definition of API gateway, is an API management tool that sits between a client and collection of backend services. An API gateway acts as a reverse proxy to accept all application programming interfaces or interface calls and aggregate the various services required to fulfill them and return the appropriate result. Okay, so to explain more on this API gateway, so I'm going to come up with a kind of a case study here. So like simple, if you get implemented microservices, so we must need some kind of action which is going to be individually, independently performed. So let's get started. So as well, we are developing software application using microservices. You might have actually different microservices like microservices one responsible for kind of one component, microservices two for second component, etc. Okay, so in this use case, I'm going to explain about catalog and product and payment. Okay, so if you look at here, I have a front end and I have a back end, right? So in the back end, I have microservices. So the back end is nothing but microservices I'm talking about, but not DB or data storage. So service one is responsible for catalog, and service two is responsible for orders. Service three is responsible for payment, like that. So I might have a number of microservices, like hundred of dozens of microservices. Application to connect these microservices called web application, right? That is nothing but a front end. So we might have web application like a SPA application, single page application based on React or Angular or .NET Core, or any mobile application, Android or iOS operating system. So anything that could be a front end application. Let's take an example of web application here. This case. So here web application is a front end, and all these microservices are backend services. To connect to these different microservices, I can use direct connection from the web app to the list of the product from microservices and get the response back to front end. In addition to that information, if I wanted to get the pricing for kind of needs to create another connection for microservices number two and get their price back, this means that services should be exposed publicly to a front end applications, which also means that here I need to have a public IPs, right? So to get access from here, I need to be having public IP access, right? Otherwise it won't be connected. And again, it is going to be returned the response back to web application. Okay. So similarly, like other services, if you want to access it here, you need a public IP, right? So hence I need to expose all these microservices with public IP. So if you are exposing your microservices with public IP, that means it is exposed in the internet. So public ID with the port number, this means that these microservices will be exposed publicly through IP address. So indirectly, they will be exposed to the hackers, right? These are exposed to the hackers. When I expose microservices with public IP and port number, indirectly or directly, these are exposed to the hacker. So that this is very security concern, because exposing to public IP address to the internet is very dangerous. So when it comes to direct access to the microservices, so definitely we have this problem, that is security. And also we have another problem. Actually, web application needs, a kind of information from two and three services, right? There's two and three services that needs to create a first connection to the microservice. So I need a kind of a result, I need a kind of catalog, and also I need a kind of order names and order list, and also I want the payment summary. So basically, I need to have three connections from this web app, right? That indirectly says that you have three round trips going to the backend servers or backend services. So that means three times you need to hit to the backend services and get the response. And again, you'll be having some, business logic here, where you will be building, you know, the consolidated response. That is business logic, you are going to build it here. So you have to put all this stuff to get the kind of a requirement. That means multiple services response. So having it this separate microservices with public IP, these are the common problems for web application. Okay. So the data will be aggregated like the first request. I could go to the microservice one and back to the data, right? Here, the details for the product. Then second request go to the issue by the API gateway to the, another microservice, and get the pricing for the products. And we can have as many as requests here, and the data will be aggregated at this level, and at the level of kind of in this web application, and then it is responding back. So one thing was security, and second thing was latency. Because of having multiple hits, my request process is going to take more time to build my response. Hence, it is very huge latency happening here. So to avoid these security and latency problems with direct connectivity to the microservices, we need to have a security network here. That is nothing but API gateway. So if you have API gateway, right, I'll not be exposing these IP addresses as public. That means, so I'll expose these public IPs to private. but it is private. So instead of public IP, right, I'm going to expose these IPCs as private IPs so that these won't be exposed to uh, uh, hacker for direct access. And this IP I'm going to expose it as public for application access, right? That means my application is going to connect to the API gateway, but not to the direct backend services. But again, this API gateway is connected to microservices because these two API gateway and the microservices are deployed on the same server, and individual services are in private IPs, and public IP was assigned to API gateway. Okay, so web application is sending a request to API gateway. API gateway will talk to individual microservices. So as it has no a proper internet connectivity here, and because both are deploying the same server, same component, API gateway will fastly connect to the individual microservices and it will fetch the response and give it back to the client. So having of private IPs, as I mentioned, for the individual Microsoft services, so I will be stopping the security risk here because I will not expose the services IPs as public. I will only expose to private. That way, I'm having the security, restriction part here. And coming to the next one is aggregate pattern. So as I have API gateway, so the data will be constructed in the API gateway, even if it is having multiple request dependency with individual APIs. So the connection to the individual APIs processed from the API gateway, right? So once they get the response back to the API gateway, the data will be aggregated. Like the first request could go to the microservice one, we get back for data right here and the details for the product. Then second request go to second service, could be issued by the API gateway to the microservice number 2, and then 3, etc., etc. And finally, we can have as many requests here. The data will be aggregated at this level of API gateway, right? Here itself, the data will be aggregated. So having this API gateway, will be easily aggregating the response in the API gateway level. So here we can create a view with the details, but contains pricing for the products, and here the residents will get back. So here we'll have less latency than previously with the web application sending the request directly to the microservices to get the aggregate results. So here we have a good internet connection. So like between API gateway and this individual APIs. So we have good internet connection. So API gateway could aggregate data, will aggregate patterns. So some other API gateway having cool features get implemented in the API gateway level. Those are could be the cross-cutting concerns. First of all, so we have kind of a cool feature was, if you look at here, authentication and authorization. So authentication and authorization is nothing but putting an authentication and then authorizing to access the required resources from the backend services. So if you have a authentication, authorization, and individual microservices, in the future, if you wanted to change the authentication logic, you have to change in all these services, which is more time consuming. Instead of that, if you have authentication authorization API gateway, so where it is a single point entry, I can directly change it here instead of changing an individual APIs and then validating my request inputs. So in future, if I want to change or make a change to the user or use the password, I'll only change it in the API gateway, but not in the microservices level. So I'll only change here, and then it is going to affect all microservices, because from here it is validating everything and then it goes to here. Okay, that is one cool feature here. And next one is service discovering. Suppose if these three microservices is having like this is something 2, and this is something 3, and this is something 2 endpoints. It's totally so I have a 7 endpoints. So if I wanted to give these 7 endpoints description to the end user to connect and access my microservices, I should give a documentation for this. And if you look at an earlier WCF services or web services, we have WSDL, Windows Web Service Description Language, where it has description of all your endpoints. So to put all this information into a single documentation, so in the latest technology, so we are going to use a Swagger, so open source documentation tool, which is easily integrating with microservices to showcase the comments of each endpoint, and then explain the endpoint input and output. So instead of integrating Swagger to individual microservices, right, I'm going to integrate this Swagger into API gateway, right? So if I integrate this Swagger in API gateway, so my API gateway will be exposed to the end user, and you can see all my endpoint in the API gateway, but not my original endpoint in the actual backend, microservices. So let us say like this particular catalog is having method 1, right? And same method 1 is exposed here as some ABC, right? So end user is only seeing this ABC, but not this M1. So that way we are going to expose a condition or a restriction to do not show my actual endpoint names to the end user, and only see API gateway level, endpoint names. So if you look at here, I have a microservice, an API gateway, which will having different kind of methods, and I just uh, put it all individual services into my API gateway, and my API gateway only showcase the API gateway level endpoint names, but not the original backend services endpoint names. If you look at here, this is my API gateway controller. I have all endpoints here. Look at here. I have all endpoints. These are coming from the API gateway, but not from the individual, services. Okay. And also I have authorization where it has register and refresh token, each token expired methods, which will issue a JWT token here. So from here, you can see all the inputs which are basically required for to access this individual API endpoint. And from here, you can try out. So as an example, like, I'm going to take something here, and if I run it, it will give a syntax like how to run this. So this is what you need to run this, and this is something you have a problem with JWT token is not passing it here. So what I'm trying to explain about here is this is what is discovering of services with individual API endpoints which got exposed in the API gateway, but not from my individual microservices. And another cool feature was retry circuit breaker. This is another design pattern API gateway where it holds the kind of validation between two services. Let us take an example. I have any service called our catalog. So this catalog service is calling inside of order service. So when I have circuit breaker, basically I have three states. One is open state, and this is closed state. This is off open. Initially, it was open state, so that my catalog service will send a request through circuit breaker, and the circuit breaker will send a request to order service. So if things are going fine and order service is executing fine and it is up and running, it will send you a response back. and same response will send it back to catalog service. If suppose if service of order service is down, or some network failure, or some internal server causing this order service is not properly functioning, then it is going to send you a response with some runtime exception to catalog service, and catalog service is unable to understand what is happening there, and it again resend same response back to client, and client is getting the exception from catalog service but not the actual problem occurring in the order service, right? So if I have a circuit breaker here, it will check the response from order service. If it is not functioning due to a network failure or internal server or service is down, it will send error code to catalog service. And again, when again some request is coming through a catalog, it won't send it to order service because it's already down it in the earlier request response process. It won't send it a request. From here itself, it will send error back to here. That way, it is a hit, reducing the hits to order service and increase the performance. And also, it will now stop sending of all these runtime exception details to catalog service, and that way it is stopping to expose all the runtime exception details of order service. And if its service is up and running, then it will transform to off state mode of open. So request will be sent through a circuit breaker with a limited number of requests to order service. And order service will process the response, and that response will be again sent to catalog service. This is something different pattern we have in microservice to minimize the request to the interdependent services to increase the performance and improvise the security. Okay, so going back to the next one is rate limit. Suppose if I have a service which will accept only 10 requests for 1 minute, and I'll implement rate limit here in the microservice or an API gateway level. And when 11th request is coming to my microservice, it will simply say that retry or wait for some time. That way, I'm going to minimize the number of requests that are coming to my service, and I'll simply say wait for some time. And that's what the customized message I'm showing to user. User will understand that the message, and he will try again after 1 minute. So instead of putting my service request in queue or taking a lot of time to process, so if I can have a rate limit configuration here, I simply say wait for some time and then retry after 1 minute. So if you wanted to see a diagrammatical pattern here, I have a client and this is my API. If I put my rate limiter here, it will filter the request. So if 10 requests are coming here, everything is fine. If 11th request is coming, it will stop here and it will send a message to the user saying that wait for some time or retry after 1 minute. That way it is, improvise the communication between different APIs to, end user. And another cool feature was load balancing. This is again kind of, if you wanted to put a scaling of application, so you have to deploy your stuff deployment in different nodes and put in load balancer, so that it will share the HTTP traffic between two servers. Let us take an example. I deployed API Gateway 1 and API Gateway 2 in different systems. And these API gateways, again, it will contact to individual APIs. And between this, I put it in load balancer here. So when requests are coming from clients or more, it will share these requests between this and this servers. So it has an health check here. It look for healthy status of this API gateway server. If it is busy, that means if it is unhealthy, it will send the request to this API gateway 2 server. If API gateway 2 server is not responding and busy, it will send other requests to API gateway 1. That way it is distributing HTTP request and send the response, and it put application always high availability. And it will share all HTTP traffics to, avoid kind of problems like, performance or, hurdle of processing multiple requests from concurrent users. And coming to the other cool feature in the API gateway was logging and tracing. So if we have an API gateway, I think you put all logging mechanism in the API gateway so that it will post or create logging files of your request with input values. and also output values being recorded in the log file, somewhere in the text file or plain file or in the database. So instead of putting all these nonsense logics in individual APIs, if you can put all this stuff in the API gateway level, it is going to take care of it. So it is something like it is useful for debugging the live servers and production servers if any problem or issue is coming to access the services. And another cool feature was whitelist of IP. Suppose if you wanted to stop access to the kind of X and Y systems, then you just whitelist those IPs so that it won't give an access to the those specified IPs. So these are some of the cool features we have in API gateway. That way we can improvise the access to the microservices via API gateway. So this is something we should look into this and integrate this API gateway for your web application. Okay, I hope you understand the concept of API gateway and the cool features of API gateway it is having inside of it. So thanks for listening to this video, and I hope you understood the concept of API gateway. It sits between a web application and the backend services and do all the operations in the single entry point. Thanks for listening to this video, and please subscribe this channel for more videos. Thank you.